Hello everyone, my name is Avery Osmak, and today I'm demonstrating the chemical traffic light reaction, which is a redox reaction where the solution changes just like a traffic light. You may be asking, what is a redox reaction? Well, a redox reaction is a type of chemical reaction in which electrons are transferred between substances. It involves two processes happening at the same time, oxidation and reduction. Oxidation is the movement or loss of electrons by a substance. An example of this would be rusting of metals. When iron reacts with oxygen, it forms a chemical called rust because it's been oxidized. The iron has lost some of the electrons and the oxygen has been reduced. The oxygen has gained some electrons. Reduction is when there is a gain of electrons by another substance. In every redox reaction, there is a reducing agent and an oxidizing agent. Now, what is the purpose of the traffic chemical light reaction? The purpose of this experiment is to teach and demonstrate what a redox reaction is and how it works. This experiment also teaches about chemical indicators, chemical kinetics, and how this process of the reaction is repeatable. When I shook the solution, it would repeat the cycle and you could do it for multiple times. So my hypothesis before going into this experiment was that the color will progressively change from green to red to yellow and finally back to green if the solution is left undisturbed after mixing. This is because the dextrose decreases the indigo carmine indicator as oxygen is used up through the reaction. I first started off with putting on my safety equipment. So I started by putting on goggles and tying back my hair, and then later on in the video I decided to put on an apron because the indicator is very dangerous and can dye your clothes. So here's when I began to put my hair back and put on my goggles for safety. I then began to make solution A, grabbing one of my 600 milliliter beakers, sodium hydroxide, and water. I put 10 grams of our sodium hydroxide on the scale and then poured it into my beaker, and then 100 milliliters of my water. I then mixed the solution to make sure it dissolved. This is when there was an exothermic reaction. I now began to make solution B, another 600 milliliter beaker, my glucose or dextrose, and water. I put 1.5 grams of our dextrose onto the scale, and then I poured another 100 milliliters of water. I again made sure to mix the solution to make sure that it was all dissolved. Now I began to make my indigo carmine solution. I pushed tare on the scale to measure out a proper measurement. I used about 1 milliliter of my indigo carmine. This is when I began to put on my apron because it gets messy and it's very easy to stain your hands and your clothes. Now this is where I got help, and my teacher helped me make the solution. We just poured it back and forth to mix the indigo carmine, and we put about 100 milliliters of water. Now I'm pouring both solutions, solution A and B, into a bigger beaker. And as you can see, when I show the solution, there is no visible change. We can't see anything. It's still clear. So that's when I add the indicator. At this point, I added quite a lot of it in, as you can see, and it turned a really deep green and then straight to red. there is the video now. So now I try to move the solution back and forth between beakers to see if it would speed up the reaction or cause another change in the color. So I did this for a couple times. I then noticed that nothing was really happening, so I decided to try and speed it up by grabbing a closed beaker and pour the solution into there and then give it a shake. That's when I started to see a much more visible change, and it happened a lot quicker. So yeah, now I began shaking it, and then you can see it turn green right there. And then I let it sit in that bottle and see if it would change back to red and then yellow. I think right here I was explaining how it was supposed to change. And I was getting a little bit frustrated, but yeah, then I saw it turn red, so I figured it was working. And then now I began to make the solution again because I wanted to see if I made it the same way, just put less of our indicator in to see if it would maybe come out like a lighter color and not as deep. So yeah, I began to make the solution all over again with the same measurements of solution A and B, and just add less of our indicator. So what really is happening during this reaction is, first, the oxygen in the air reduces the blue solution that is colored by the indigo carmine into a green color, the color of its oxidized form. So as soon as I add the blue indigo carmine solution into our solution of solution A and B, it turns the green color. The glucose that's in solution B starts to reduce the indigo carmine, and that's when the green solution is left to stand, first turning red and then turning yellow. The indigo carmine is fully reduced once the solution turns yellow. This reaction can be repeated by shaking the solution, as we saw. This reintroduces the oxygen into the solution, oxidizing the indigo carmine once again. The solution combines with air when shaken or poured out, as I was doing when I poured both solutions back and forth, and the oxygen oxidizes it to green once more. In this reaction, the glucose is the reducing agent as it becomes oxidized and gives away its electrons. Okay, so now I'm adding a lot less of our indicator, almost not enough, so I ended up putting more in after because I noticed it was more of like a yellow color, not the green that it should have been. So I poured it back into the beaker with the closed top to shake it. And then, yeah, now I decided to put more of my indicator because I noticed right there it's like more of a yellow color, not the green. So I put more in, and then I began to shake it again. Still sort of a yellow color, so I ended up adding even more, and now you can see it's on the table over there in front of my teacher. If you look really closely, we're talking and we don't even realize, and then all of a sudden it changes red. You can see my teacher's reaction. There it is. And yeah, so it turned red. At this point, I was freaking out because I didn't get it on camera, really. It wasn't a clear shot. But then we set up a time lapse, and this is what we got. We couldn't really see the green at the start because it's right when you shake it, and then it turns immediately red. So then I got some pictures to kind of show a better demonstration, and then also I slowed down the time lapse to show each stage of this reaction. So there's the green, and then the red, and then the yellow.